Oh, sorry, I'm just great. Hi guys. So yesterday while I was adding some final touches to my slide, I was informed that the TensorFlow logo changed, and I was extremely devastated because the new one is very ugly, and I don't want to keep my opinions to myself. So, yeah, so today I'm just going to be talking about TensorFlow and how we can use that to think about machine learning and how we can use that type of research-based thinking in the future. So TensorFlow, isn't that logo just, what is that? I don't know. So TensorFlow is just a library of different machine learning tools that you can use to create your own machine learning modules on your phone or on your computer. And just to clarify how powerful of a tool it is, it's actually been used to discover new planets by comparing the distance moved of the planet relative to others. It's been used to screen for blindness. It's even been used to alert authorities of illegal deforestation activity. And most of you probably know what machine learning is. It's essentially just a way of trying to get computers to learn about data that you feed it without explicitly telling it what it is. So as an example, if you fed a computer 10,000 images of cats, at one point it would realize that, oh, okay, this is what a cat is. But the thing is, we've kind of been trained to think of machine learning as just a tool and not a way of thinking about data. So in the same way that Java, for example, is an object-oriented programming language in the sense that it divides things into classes, and those encapsulated classes can interact with each other, and how divide and conquer is a problem-solving method where you divide problems into smaller subproblems and then solve those recursively and then join them again. Machine learning also has many different paradigms that you can use to think about different ways of processing information. And a paradigm is just a set of values that you can use to solve or approach a problem. And in that sense, TensorFlow isn't just a tool, it's an example of a DataFlow paradigm. Have any of you guys heard of that before, by any chance? So it's a pretty simple idea. So if you just look at this graph, which will go into more depth right now, it essentially emphasizes the movement of information between operations as you're creating your machine learning model. And essentially, the main focus is trying to track the flow of information as it goes through the different parts of your model. But why is that particularly relevant, and why is that powerful? Why is that type of idea powerful? Because when you combine TensorFlow with the DataFlow paradigm, you can do really incredible things like building neural networks line by line. And this is just an example of one layer of code that I wrote to create the CNN, or a convoluted neural network. And you can also do really cool things like use TensorFlow for smaller devices like on a Raspberry Pi or on your phones. And you can actually run different models like image recognition models on your phone. And because of the way it validates your input information, as you can see in the previous picture, a lot of the information that is processed is working in parallel. So in that sense, DataFlow works are essentially parallel, and a lot of the things can work at the same time, which makes it incredibly powerful. So building on top of that, because TensorFlow is so cross-platform, it can work on multiple different platforms at the same time. So you don't just have, like, it's not an example of 20% of this is meant for inference, and then 80% is run on your computer to build your model. It works equally across all platforms, and that's what makes it a unified interface. And why is that important? Because in that sense, it's important to realize that machine learning doesn't have to be the way that it is now, and we can think about it in different ways rather than just a DataFlow paradigm. So an example of that would be associative machine learning, which is actually a new model of machine learning that's coming up where we try to get computers to learn about different things, not based on similarity, but based on context. So for example, if I gave you 10,000 images of cats, our current DataFlow paradigm would try to find what's similar among the images, and it would say, oh, okay, so that's the cat. But obviously, as you can imagine, that has many different flaws because what if all of those images had a similar background image? So in that sense, that model wouldn't detect the cat as the cat, but the background as the cat. So in that sense, when you focus more on context-based machine learning, you think about more meta information, like where was this picture taken? Where is the cat placed? Which time was it taken? And you take all of that information into account, and it's really similar to the way that people learn. Because when you learn about something new, you try to base it off of what you learned before. So in the sense that if I gave you a completely new dish, you would be like, oh, this is really similar to this other thing and this other thing that I've experienced before. So in that sense, associative machine learning is just a holistic model of machine learning. And this is a really powerful concept because it implies that we don't have to stick with the way machine learning is created now. And this paradigm essentially allows you to work on more research-based machine learning and create your own ways of thinking about data processing. Yeah, thank you. So if you have any questions about any research that I've done or anything, I'm not a professional by any means, but I'd be happy to try and answer your questions if you have any.
Questions?
Have you got a demo on the phone that you could show on the screen?
Oh, unfortunately, I was gonna try to do that, but I thought I wouldn't have time to. But the thing is, you can actually go and do that on your own. It's really simple. So TensorFlow has that created out for you. You can essentially go on the TensorFlow Lite website and download that onto your Android or iOS phone. So I think there's image recognition and text recognition and 2 others. So you can actually take a picture of an object on your camera, and then it'll tell you what that object is. So it's really easy to do that. So you can try doing that as well. Yeah.
One last question.
I see a question. What's the difference between AR and machine learning?
And AR?
AI, artificial intelligence.
So machine learning is a subset of artificial intelligence. So artificial intelligence is the idea that what if machines could get consciousness and think like human beings? And machine learning is just a part of artificial intelligence, the same way humans are not only defined by their learning, but also other different things like breathing and eating and walking. In that same sense, machine learning is just a part of what defines AI, and it's not the whole thing that makes it.
Awesome. Thanks very much, Ayesha.